Let's look at this example involving confidence intervals. In this particular example, we're asked to construct the confidence interval estimate of the mean. Listed below are amounts of arsenic in micrograms per serving in samples of brown rice. Use a 90% confidence level. So already you should note that in this particular problem, the population standard deviation is not known. So what that means is that we're going to end up having to use the t-table. And that's okay. I mean, in real life, very rarely are you going to know the population standard deviation. So, remember, confidence interval. What we're looking for is what here? It's the confidence interval estimate of the mean. So what that's going to look like is this. So it's going to be, our interval is going to be centered about what we're trying to estimate, which is the population mean, which is mu, x bar plus e, where in this case, e, remember what e is? E is called the margin of error. Okay, E in this case is going to be our critical value, which we're going to get from the t-table, times this fraction here, where the numerator is the sample standard deviation, and the denominator is the square root of n. So, what we're going to have to do is get out our TI-84, okay? We can easily get what? First of all, n is the number of items here, which turned out to be 10. We're going to find x bar and s using the one variable statistics. So on your calculator, on your TI-84, turn it on first, okay? Go to Stat, Edit, List. So list 1 happens to be empty. So what I'm going to do is I'm just going to enter in these values. These values are 5.4, 5.6, 8.4, 7.3, 4.5, 7.5, 1.5, 5.5, 9.1, and then finally the last value is 8.7, and exit out of that. So now what we want to do is calculate the one variable statistics. So go to hit the stat button. We want to calculate one variable statistics of what? Of list 1. So what we see here is that x bar is 6.35 and s is 2.325 actually. So let's write down what we have here. N, of course, is 10. S is 2.325. X bar is 6.35. So what else is needed here? Well, what we need is our critical value, which is going to come from the T table. So what was asked for here is a 90% confidence level, which means that the area in 2 tails is 10. Okay, so we get out our T table, which is right here. Area in 2 tails is 10%. Now, what number do we pick here from the left-hand column? Degrees of freedom, that's going to be 1 less than n, so that's going to be 9. So take the 9th row here, go to area in 2 tables, right there. So our critical value is 1.833. .833. So what we have to do now is plug all of this in. Okay, I'm trying to find a confidence interval for the mean. X bar is 6.35. E is going to be this number, which is 1.833, times S over the square root of n, where S is 2.325 and n, of course, is 10. So when you do all of that work, what you should end up with is this: your confidence interval should end up being 5.00 for the left endpoint and 7.70. So what does this confidence interval say? It says that there is a 90% chance that this interval contains the true mean of the population, right? What we're trying to estimate is the mean arsenic level in brown rice. Okay?